Alright, 5.4, solving rational equations. Before we begin with this, I want you to understand that in order to stay consistent, the book really deviates in 5.4 and then does something different when we look at inequalities. What I'm going to do is demonstrate this, assuming in such a way that it's consistent throughout this chapter. So you're going to look at this and maybe look at it slightly differently, but then when we look at the later on ones, you'll understand why I'm adhering to the same policies in order so that you do the same concept once throughout the entire chapter. Alright, example number 1, solve each rational equation. So we have A and B right here, alright, and A is set equal to 0. What we need to do here is in the first example, is we have one fraction where it's equal to 0. The whole goal behind everything we do from here on is to set it equal to 0, or if here was a different symbol, we would have always something with respect to 0, so comparing it to 0. In this question here, we have a fraction equal to 0. When would a fraction equal to 0? Well, the only possibility is when the numerator is equal to 0. But before we can do anything with the numerator, setting it equal to 0, what we need to do is state the restrictions of the bottom. What this means is that provided that x does not equal negative 3, so provided we don't have a value of negative 3, we can determine the value of the numerator to make it equal 0. In this case, that will be, we are going to set x minus 5 equal to 0. And what that will give us is, just a minute, what we're going to have when we have x minus 5 equal to 0 is we're going to have that x equals 5. Alright, why? Because it's only the numerator that has the possibility of being 0. If the denominator is 0, it's undefined. So which is why we state the restrictions. So we state the restrictions of the bottom and determine what values will give you the numerator equal to 0. Let's look at the next one and compare this. When we have this, x plus 3, one fraction equals another fraction with a bunch of variables. First of all, let's state the restrictions. There we go. And we're going to find a common denominator and set that equal to 0. So the common denominator is going to be x minus 4 times x minus 2. Or x plus 2, sorry. So x minus 4 times x plus 2. And the numerator, so this denominator has x minus 4, here it is, but it doesn't have x plus 2. So whatever I multiply to the denominator, I must multiply to the numerator. So x plus 3 gets multiplied by x plus 2. And the same here. We need to move this to the other side so that there is nothing over here, folks. So we're going to subtract. What are we going to subtract? Again, a common denominator. X plus 2 is the denominator. We want this whole thing to be our denominator, so it's missing this piece right here. So I take whatever I do to the denominator, I have to do to the numerator. So it's going to be x minus 1 times x minus 4. Now, next step is to expand the numerator. So you get x squared plus 5x plus 6 minus, and in brackets, x squared minus 5x plus 4, and we set that equal to 0 with the denominator. As such, collect like terms, and you get on the bottom is the same denominator, folks. In the numerator, you have 10x plus 2. And the denominator just there, folks, just so that we know, there should be a plus there. There we go. So 10x plus 2 over the denominator. We have the restrictions placed on the bottom. So the numerator, when is this numerator going to equal 0? Well, folks, that's when x is equal to negative 1 over 5. That means if x is negative 1 over 5, the whole value of the expression is 0. And again, x is not equal to any of these numbers, so we don't have to worry about that. All right, that's literally how you do these questions. Okay, let's look at another example. Example 2. Yasmin bought a case of concert t-shirts for $450. She kept 2 t-shirts for herself and sold the rest for $560, making a profit of $10 on each shirt. How many shirts were in the case? So in this question, we have to be very careful. We need to read the question and be able to determine what we're looking for. So we have a case of t-shirts for $450. So she paid $450 for X shirts. She kept 2 t-shirts for herself and sold the rest for $560, making a profit of $10 on each shirt. Now some of you are going, well, she made a profit of $110. Be careful, folks. She kept 2 t-shirts for herself, so that means she made more than $110. Okay, she made $110 with 2 t-shirts less. So we need to set an equation that represents this. We need to know how many shirts were in the case. So we're going to let X represent the number of shirts in the case. So the key here is this value right here. This value that we see here, this is the most important value. Why is that important? Because this is based on how we're going to find the equation. The profit per shirt was $10. So how do we get profit? Well, profit is generated by revenue and by cost. Revenue minus cost. Revenue is how much money she made was $560, okay, and then but for 2 less shirts. The cost was $450 for X number of shirts. So let's try and calculate all the different values here. Profit per shirt was $10 per shirt. Revenue per shirt was $560 over X minus 2. Cost per shirt was $450 over X. So we bought X number of shirts for $450. We sold X minus 2 shirts for $560, which gave us a total profit of $10. What does X represent? Well, it represents the number of shirts in the case. Let's keep going. How do I make this now into an equation? Well, $10 is the profit per shirt. That equals the revenue minus the cost. So, using this equation, we can determine the common denominator and expand. So what we're doing here, folks, okay, so we're going to do 2 things at once. First of all, a common denominator, and we're going to move the 10 over. So all of this will be over a common denominator, which is going to be this. Now, X and X minus 2 are our denominators. That becomes our common denominator, and we multiply everything by what is missing. 560 times X minus 450 times X minus 2 in brackets minus 10 times that whole denominator. What we can do now, oh, be careful, before we expand and maybe simplify, we should probably state our restrictions. X cannot equal 0 or 2. Now, that's logical mathematically, but let's look at the problem. If she had 0 shirts, means that you couldn't take away 2 shirts to make this profit, so that's not possible. Also, if she had 2 shirts here, maybe 2 take away 2 would mean that she would have 0 shirts to sell, which doesn't make any sense. Now, let's look at another number. What about 1? If I had 1 shirt here and 1 take away 2, that means how can you take 2 shirts away from 1 to get a profit? You can't. So really, in this problem, in reality, X has to be strictly greater than 2. We have to have more than 2 shirts in order for 2 shirts to be taken away. All right, keep this in mind later on when we answer our question. So, we expand, and then we're going to collect like terms, and then we're going to common factor, because it makes it a lot easier when we common factor, because we could probably look for factors that work. And lo and behold, when we do all this, again, there's the common factor step. We end up with factors of the following. What are these factors? Well, the numerator is factored in order for us to find out what values will make the numerator equal to 0. Negative 10 cannot become 0, but this bracket can become 0. What value must x be? Well, hopefully you're thinking 18. And the next value, what value must x be here? Hopefully you're thinking negative 5. And these are the two values. Why is negative 5 not possible? Think about it, folks. We had a restriction on the domain. We said x must be strictly greater than 2. This value is not valid because x must be greater than 2. Therefore, there must have been 18 shirts in the case. Alright, we're going to stop the video here and we're going to go on to the next problem on the next video. Okay, see you soon.